All right. So first, thank you all for the insightful presentation, for sharing a little bit what life is also on the other side, besides the wrapper of TechCrunch or Wired or whatever you guys are using to get informed about how this field is moving. I have a couple of questions myself, and I would like us to discuss them briefly, and then afterwards we will open for questions from the crowd. First things first. We have a very diverse set of people with different experiences. Is it far more expensive to do AI, to do data modeling right? What do you guys think? We can start with the lady, of course. Yeah, to do it properly, to do it, because, okay, a little bit of context behind the question. I've worked with a lot of startups. It's very easy to get something up and running, right? It's very difficult to get it up and running properly with the bias, with, good outputs.
It's a real problem. How do you balance the speed with the accuracy? Which is why I think a big part of data modeling is also about getting feedback. So if you want something quick and dirty, you do something quick and dirty, and then you get a lot of feedback, and you reiterate your model and keep reiterating it.
Yeah, I would say it in this way that actually, getting something up and running is very crucial to gather the experience, the data, and to really understand what's going on. Because at the end, if you try to optimize your model for infinity, you might have the best model on the planet, but you will never actually make it to market. In many markets, good, or in many situations, good enough is 80-20.
Yeah, I actually think it's kind of like opposite. Like usually startups, they don't really care. They don't think so much about all these potential ethical or biasness issues. So they just kind of just roll it out and think about it later. So I think it's kind of good as well to kind of balance it with what are the potential ethical implications of your model. Yeah. So that's what I think. Yeah.
I think usually it's 90-10 rules, right? You spend 10% of the budgets on 90% of the time of the work, and then the 90% of the budget in the last 10% of the work.
Jason?
I think data science teams, we are afraid of the overhead of doing things right. If you within a data science team, everyone kind of understands each other and can kind of move fairly fast. But the moment you bring in a team that is not so, maybe doesn't understand it so well, like a legal team, I think that's like suddenly everyone will know what can happen with the project, take 5 times as long and cost 5 times as much, and not be going to production and stuff.
All right, so you basically advocate doing things and then doing things right later, or?
I think it's important to show what it should be and not bring everyone in too early.
Okay. And with regards to the 90-10 rule, I've heard a very similar rule with where does the importance go when it comes to AI or data science projects? Is it how do you feel about this statement that 90% of the value is in the data and 10% only is in the algorithms?
Tough answer to that. Well, I think to me that is actually I wouldn't say that is 90% is on the data and 10% on the algorithms, but I would say that substantial amount of time need to spend on the data, right? And basically, to a certain extent, you are right. Getting the data right is not an easy task. Cleansing it, cleaning it up, and so forth takes quite a substantial amount of time, right? And depends upon the type of applications. If you are doing a mobile apps to do image recognitions, the images are a lot of the images are already around and whatsoever. You could just pick them up. But if you are doing medical records, then it's a whole different story altogether.
I'll actually say false, maybe wrong dichotomy. So
Yeah. Yeah, whatever. Well, then whenever the model is wrong, we just call it serendipity, right? And how about getting right data? I mean, I assume all of you have basically grappled with getting access to the right data. I also assume that the ones coming from larger organizations have find that slightly easier than others. One thing?
Yeah, I come from a large organization, but I can see that it's very difficult to get data. And you mentioned that in insurance, you know a lot about your customers. But think about it, how many times do you buy life insurance? It's just one premium. How many times does an insurance agent come back to you? So, yeah, the touch point is actually really difficult, which is why a lot of external data is trying to be acquired to actually augment this kind of data.
Data quality is actually one of the key parts for let's say, this event recommendation system as an example. And there's so much junk email that's coming through, spam and all kinds of crappy data that you get about the event. For example, if you have a sign up for a class that lasts 3 months, it costs $700, of course you wouldn't even have the recommendation, right? Or if someone's testing something, so you wouldn't recommend something that says test 20 times. So you need to be able, in production already, to filter this out immediately the moment the time goes through. Of course, you need to have good algorithms on both ends to clean your data before it goes into your model, right? But of course, that's the problem exactly with the bias, right? You filter it out in your sample, and then suddenly it pops up in reality, and then what are you going to do?
Yeah, I agree on the data quality issues. So, for example, our case, lots of the drivers are using crappy hardwares, and you're not even sure, whether they are where they are. So, like, it's you have to, properly clean and understand, what are the possible, hardware-induced errors in the data, basically. Yeah.
So definitely data is a challenge. Most of the algorithm right now depends upon the data. And that's the reason why the research community right now is looking at a whole different type of techniques to actually how to actually make learning algorithms to learn with lesser data. Transfer learning is one of them. One-shot imitation is another one, and there are many other things that's all coming out. So there's no doubts that there is, but also the other thing is that people are looking at how do we actually could the machine learning algorithm learn with lesser data, right? That could actually change. If that is successful, that could actually help to change the paradigm a little bit.
Coming back to the question of is it easy to get data in large organizations? It's a definite no. I think a lot of our team, we spend lots of time waiting for data, waiting for access. Just the reality of it. I think what Zane said earlier about startups being a bit more like kind of in a wild west and scraping whatever data they want and kind of getting away with it. That's certainly something that a large organization cannot get away with. But yeah, we should. I think. I think that if you're small, you can kind of like plead ignorance or kind of hide somewhere. But if you're big and the impact of bad publicity, if something like that would get found out, might be just too much to bear.
All right, and maybe, two more questions. One is, where are we heading with all this? Like, is singularity near, or is it depending on how much you've slept last night? Because there's a lot of conflicting opinions. But to be quite frank, being in the trenches, you don't really get the feeling that we have anything close to advanced, non-specialized AI.
Well, in my opinion, it's highly overrated what we're talking right now in AI. It's at the end of the day, it's simple linear algebra and some statistics that are applied at this stage. We're very much at the beginning, in my personal opinion. Of course, we now have the infrastructure in place, and I think that's the game changer. What we're observing right now, we now have these huge decentralized systems where we can store data everywhere on this planet, and we have the computing power. And Nvidia, is supplying GPUs in this regard already, right? So we have the technical abilities to do it right now. Now we find applications for it, but this has nothing to do with really general intelligence yet, right? And I personally believe we're still 10 to 15, maybe even 20 years away from actually achieving that. But, well, I might be wrong, because now, of course, there are many more people working on this problem, or problems in this regard, and you never know, right, where we will be in 10 years.
I would have to agree that we are at the very beginning stage, and all the infrastructure, I think you're very lucky. In Allianz, it's not that advanced yet. We are still working on very legacy systems, and we are trying to revamp that in the whole. But the good thing is, it's because of all this hype, right, that people are starting to notice that this is important and they need something like that. And I spoke to startups also, and they're hiring data scientists right from the start, but they don't know how to use them as well. So, and they asked me, I just lost my PhD, and how should I do this? So, yeah, it's still a long way to go.
Yeah, I agree that general AI, like Skynet style AI, is still far away. But I think like even the simple model, right, like just a single machine learning model, can also inflict a lot of harm, and it's best to exercise prudence. Like I just read an article not long ago about EU passing legislation to kind of like enforce that you have to explain what whenever a model makes a decision, and then the citizens has a right to ask for the algorithm to forget, to revoke their data, basically. So like how do you untrain a model that has been trained on data? So you have to, there's a lot of intricacies on this that you have to be.
How do you untrain a person?
Use a bat to knock on the head.
Reformat.
Right. So from my perspective, the areas of artificial intelligence, or rather, I would say that generally right now is just simply machine learning. I would say artificial intelligence still a pretty long way, because what we are talking in the room right now here is basically all about machine learning. The whole bunch of artificial intelligence is very broad. There is symbolics, manipulations. There's many other things of techniques which we have not actually considered in this discussion. But what I want to say is in the area of machine learning. First of all, there is many aspects. If you look at the human being, there's many aspects of it. One of them is a perception. We see things, computer visions. We hear things, automatic speech recognitions. We understand language, NLP. Computer vision has reached a stage where we can start to apply. We have not really fully understood how it actually works inside it. We know that it works because we get a very good percentage. It works. We have applied it. Natural language processing, automatic machine translation is in the pipeline. Is working. Baidu, Siri, Apple's, all these things are all, but they are still in the stage. But they are what I call them in the areas of basically perceptions. It is still not generative. A human being is generative. So in terms of generative, in terms of the research, we have made some step forward. There are certain new algorithms that's coming out, gangs, for examples, that allow us to actually generate models, right? Coming up with ideas, giving out things. Because as a human being, when we generate ideas. So there are algorithms that are able to generate ideas, but they're still in a very primitive area. The next part of a human intelligence is intuition. How do we then have intuition? Now, we say that we have made some progress in that. AlphaGo is one of them, using reinforcement learning and so forth. The Libato, we use counter-fracture regrets minimization algorithms. We have managed to do a small little part of what the human being can do. But we are still not able to understand how to actually computerize emotion and fully understand intuition. So we're still a pretty long way to go. We are making small progress, and that is the stage right now. How long it will take, whatever we say right now is totally wrong.
I think I empathize with the people who think about the singularity, and I think it's because even though we use the word narrow and broad, people still don't really kind of appreciate the narrow and broad. If you look at a child, if a child can say string a sentence together, you would kind of assume that the child knows that, that's a ball, that is a cat, that's a dog. But in our world, like that's like two totally different computer programs with like almost no generalization between them. So when people see like a Go or a Watson winning Jeopardy and all these things, people make that leap. Oh my gosh, if a child can string a sentence, know this much, a person who can win at Jeopardy should know this much more. And that breakdown, which is very intuitive for a human to make that jump, kind of like is completely false in the world of machines. I kind of see AI as like just optimizing machines. And I think to what Zane said just now, I think it's just long before any of those issues come, we just need to make sure they optimize towards the kind of world we want to live in.
Thank you. And last question. What is the top challenge that you're facing working with the field, working with the technology? What's the top challenge for you right now?
I think as data scientists, we live in our own bubble, and that's very real and very dangerous. And sometimes there's this culture that, we know all these like technical things and everyone else doesn't, and we're kind of like smarter than you, and no one will ever understand us, and we go in this bubble, and we kind of have this thing which is really unhealthy. And I think it's a cultural thing. It's not, we have this saying, the hard stuff is the soft stuff, right? So it's not like, if products fail, it won't be about, I lack power, sorry. It won't be because I lack GPUs or I lack like modeling capacity or things like that. It'll be more because of these cultural things. Because, I think I'm scared of practitioners being together in our own echo chamber.
The biggest problem right now for us is talent, right? So looking for talented people that is working in this area is very, very limited. And this is one of the biggest challenge that we have.
Yeah, personally, I feel that the biggest challenge is just to keep up with the advancement of the field. It advances so fast. And professionally, I think the biggest challenge is, the business, the senior management perception of data science. Like they don't really get, what is it about. They just, want to be in because of the hype and stuff. So it's important to educate them and on this. So yeah.
Well, for me, it's finding people with domain knowledge at the end, similar to what you said, talent, right? That truly help and understand the world and then build models and basically create the future.
I agree that the biggest challenge is so breaking out of our bubble is important because we need to talk to people to be able to understand what we don't understand. But as data scientists, I think for myself, actually, I'm a geek. I started off as a researcher, right? I hate public speaking and I hate being in front of people, and I don't know how to communicate with people, right? So yeah, that's one of the biggest challenge I see for myself as well as some of the people that I meet. And the next biggest challenge is that we need diversity in the team. So we need more girls. In tech, yeah, we do need more. I just counted like a handful, but yeah, diversity.
Well, thanks everyone. I would like to open the floor for questions. So just pick up a hand and then pass around the microphone.
Hello, I am Mantas. I'm visiting researcher now at Skills Future Singapore. And I wanted to test, I don't know who would want to answer, or a couple of you, my question. From your presentations, I made up sort of a little structure in my mind of what are the main issues with bias. And then you might have the model bias at the top, then you might have the bias of data that is not properly representative of the underlying population, but then also you would have biases or inequities in the population itself, like there was the presentation of CEOs who are mostly white and male, but that's not actually bias in the data, not necessarily. It might be a feature of the society underlying it. So to you, what do you think would be the most challenging of the three biases, or the most important to solve or the most difficult to solve? So I wanted to test that with you, or maybe I'm wrong in my mind about the problems. Thank you.
So let me get a shot at this, right? You are very right. It is very difficult to distinguish between features, bias, and so forth. And there's a reason why. One of the things is that there are people are trying to able to explain it, rather than trying to say that, well, this is a bias. If I have an algorithm to say that this algorithm have done this because it has made this decision, right? I would then able to say that, well, the algorithm is making decision based on this sort of data and whatsoever. It could be, and in your opinion, it may be a bias, and in some other people's opinion, it may be a features, right? And so I would advocate algorithms that are able to explain itself, rather than trying to try to find where are the bias within the data or where are the bias within the algorithms. Because it always exists, no matter what you do with it.
Yeah, I agree with Simon fully. So I think that the bias is just an artifact of our human society. The humans are biased, right, regardless of whether they admit or not. And I think at least the silver lining is that using algorithm, if we are conscious of potential bias, then at least we can dissect it and understand it. But then imagine, for example, a hiring manager, he can come up with various excuses of not hiring this person because of maybe it's legit reasons, or it might be due to his inherent bias. But then, but if it's an algorithm, at least you can dissect it and you can understand why is it making this decision. And if it's human, you can't really dissect his mind, right? And he can lie to you and say, it's because he can't do this, or he's not up to this. Yeah. So that's my take.
Well, if you look at the CEO sample, right? I mean, you have white males. So, of course, this is how the world looks like. So the model that we would build underneath is that a CEO would be white and male. So now if you want to hire someone, of course, you're free to hire someone else. But if you now would then, let's say, build a model to predict the next CEO of Disney, then of course your most probable choice would be white and male. And at the end of the day, you have a model that describes the reality, the domain knowledge is fully applied, so the reality is that it would be white and male, but not female and black. And yeah, of course, it's not binary at the end. There are many colors in between, and many, genders are not too non-binary, but at the end, what you want to have is you want to describe the reality. You need the domain knowledge in order to build a good model. And of course, there's a natural bias in everything. There's nothing that is without bias. It's just how do you work with it, how do you live with it, and how do you apply it in your model. That's where the domain knowledge is so critical to building correct models, because you need to understand what influences your view of reality, because everything is a representation of your reality, and everything is a representation of you, how you personally view this. Right? Because by building the model, you can now choose, right? Do you want to have this as a model that all CEOs are white and male, or do you want to balance it in a different way? So you might have other factors like married, non-married, has dogs, doesn't have dogs, which car this person drives, or whatever, right? So that you can choose many features that describe your reality, and that's the data science process to now find out what influences or what is meaningful for your model at the end.
Just to unstack slightly, probably the question is, what are you really looking for in a CEO? So are you looking for the traits that she or he is exhibiting, or are you really looking at whether he's white or not, or male or female?
Just to pick up on your three, the way you segment the problem, the last one, the fact that our world is biased, or at least it looks that way, is not a data science problem. Look, you've gone from library dplyr, import numpy as NP, to what is your ethical stand on equality, and it certainly is a problem. I'm not sure we or anyone else will be able to solve that kind of thing. But it is interesting that the advent of interpretable models might force us to confront these things, because unlike people who will lie, models will tell you why they made this classification, and there's nowhere to hide, and it might actually cause us to have to confront this.
Hi, I'm Daniel, and I'm not exactly a very technical person, so I'm going to ask something more of a layman. I guess just now Simon was sharing that we are more civilians more than ever during this era of time with all the cameras and all. So I was just thinking of the movie Minority Report, preventing crime through AI and image recognition. So how does this model biasness actually affect this kind of thing, or is it possible that in the near future that we are able to prevent crime based on image recognition? And what are the obstacles that, because of the biasness of the algorithm that's going to, they charge someone as innocent, or catch someone as innocent thinking that he's going to commit a crime?
So, the minority reports, we have not reached the stage of minority reports yet, where you have able to predict the crime before it happens. But China is already implementing a system, and you could actually do a Google search right now. They already have implemented a system that's actually trying to, I wouldn't say to predict, but trying to identify where are the potential crimes is going to be, right? Now, that is part of the things was based on facial recognitions. And you are very right, and this is extremely, very, very dangerous, because facial recognition is based on the amount of database, the images that is being collected that they have. Remember that, the words was that. And I say again, when you train any of the neural network, it depends upon the type of data that you have, the space of the data that it occupies. That is where the neural networks will perform the best, right? For that particular space. Anything that's outside the space, it will not perform that well. But you wouldn't know unless you're able to dissect your algorithms and tell you exactly what your algorithm is telling you. That is the reason why, at the moment right now, there's a community advocating right now is to do explainable artificial intelligence. Is to, when you do such algorithms, why your algorithm is making such decision. And that is very extremely important, especially for civilian system like this.
I'll just add on a related point. So in my talk, I talk about two papers. One is quantitative input influence, QII. That paper, the use case is actually exactly that, predictive policing. So on the basis of things that might happen in Minority Report, I think there's a big body of work to tweak those models to make sure that it's not done irresponsibly. One thing interesting is I do have a friend who is actually an artificial general intelligence researcher, has been doing it for many, many years, over 2 decades, and one of the convictions she has is that AI QA will be a very big job in the very near future. So, I sometimes think we are a bit misguided here in Singapore, where these X people are going to be displaced from work. Let's give them some money and train them in Java, Python, and make them engineers. I think it makes a lot more sense that someone, say, working on a manufacturing line in QA comes to do AI QA. I think that makes more sense. And I think, there's many other jobs. It's not the development of data science or AI models, but it will be the management, administration, and all the stuff around it.
Yeah, so I think that is a big pool of work that's coming.
Thank you.
Hi, my name is Shrey, and Simon, you mentioned before that obviously the sort of next step moving forward would be to have the machine learning algorithms to be able to get better insights and more unbiased insights through lesser and lesser data. But with short samples, would we not be, I guess, compromising the integrity of the fact that shorter samples would be more biased as opposed to bigger data samples?
Definitely.
So in
Definitely.
that case, how are you still having the right insights with unbiased data?
Shorter samples doesn't remove the biasness. Remember that. Smaller sample allowed you to get to what you want to achieve faster. It does not remove biasness. Period.
So will there be a trade-off there in terms of how soon we want, and when do we know what the right trade-off balance would be?
So that's why you need to be able to dissect your algorithms. Period.
Hi, I'm Rico. I work in advertising, but maybe contrary to the common stereotype, I'm asking more of the ethical type of question because we know that we don't have morals and such. But when you were talking about Go-Jek, you were talking about transparency of the predictive model, and this is question to all, but if we think about algorithms that are affecting our lives, they are not transparent, that they are all Facebook, Google, and there's lots of talks about bias in those, which wouldn't be surprising because we are all biased people at some point. Should we have at some point some level of almost like, okay, these are the parameters you are getting your news feed, and of course it's tricky because it's their main business advantage, but do we need some kind of, in the future when everything will become predictive, almost that you can see why this is recommended to me, why I'm seeing this, and should people be able to know that in the future?
Yeah. So that's a very tough question. So I think one way about this is that like for example, I can only speak for Go-Jek, for example. Like one of our mission is having a social impact on people's life, and of course we want to make profit, but besides profit, right? What can we do to help the people more? And I think once the senior management has this on their mind, I think a lot of these issues are basically ethical issues and fairness can be resolved, right? If you put your mind into it, and if you spend time communicating it out. So I believe that I can't speak for advertising because I'm not very familiar, but I think this really depends on what's your mission and what's your and another way that I think of is that like for example, the way newsfeed works, right, is that they based on your interactions with the articles or your friends, and it's kind of like a self-fulfilling cycle where you always get to see things that you saw, and you always get shown things that you saw. So it's in some way it's one of the biases that I talk about in the 5 potential sources of bias, and one of it is the emergent bias, where you have not wrong, you just get shown what you have seen, and then you just can't escape it. So I think maybe for advertising or for other kind of business, one way they can think of is how do you break that? So how do you show people things that might interest them, but they haven't seen it? So I guess I'm not sure if I answer your question. Yeah, is that clear? Yeah.
More and more we're going to see research that helps us
Hi. Something I found useful is like those portals like Steam, as they now implement this like never-ending scrolling thing, where it's like, you know, they'll just give you more and more recommendations, and beneath each chunk, they'll show you why. So it's like, you are seeing this because Zane liked this game. You are seeing this because you played this other game recently. You are seeing this because... So I assume that would be like an expression, a UX expression of the strongest feature of why you're seeing that in your feed. And I think something like that would be great if you just see more of that.
Well, I personally believe it's actually super important to be able to explain your models and to explain why a specific algorithm decided in this way. At the end of the day, if you by yourself don't understand how the system works, then of course how are you going to improve it? And I believe every data that you leave somewhere, of course, will be used somewhere at some point in time against you. But of course, if you know, all these different features, all these different data points you leave, of course this will be used. So of course it will be part of some model at some point in time somewhere. So from this angle, having explainable models is actually a moral, well, it's very important to have right off the bat. Moral obligation, that was the word I was looking for.
Hi, my name is Ivy, and I actually come from 100 Offers. So I'm working on the talent side. So we help quite some company looking for data scientists, data engineer, and at the same time, I work with quite a lot of them. So the thing I like all of you said, like the talents is very important in this field, and it's only at the beginning. But a lot of things I realized, like many people are interested in going into data scientists, but at the same time, a lot of our companies we work with, they say they require a PhD like as a must for the data scientists. So I don't know, sometimes they ask my advice. I also try to understand, like, should we advise them to, you know, get a PhD or any other thing they should try to learn at the moment so that they can get into this field as well? Yeah, that's a question, because it's also short of talents, according to what I said just now. Yeah, that's my question, I want to understand.
Actually, it depends on what you want to do with in the areas of machine learning, right? If you are looking at applying machine learning, you don't have to be. You don't actually need a PhD. There are tons and tons of algorithms that's available, you know, and that, of course, you need to actually understand when you use it, right? But you don't need a PhD to do that. Now, if you are developing new algorithms, right, state of the art, let's say you want to have a new versions of GAN's generative adversary network, and now you want to have some form of that cascaded with LSTM and whatever to do some sophisticated thing. Then you need somebody who really understand the deep understanding of it, the mathematical aspect of it. Then it's a whole different skill set. A PhD doesn't mean anything, right? A PhD is only get you to write the thesis, and you spend the 7 years trying very hard that you know that the guy has written the thesis. He's not the most brilliant person, right? That's what my wife always tell me. Right? It's just that you have done the hard work. In fact,
sample is not big enough.
Yeah. Well, I think my wife says that, you know, after my wife, I don't need Googles anymore. But anyway, my point is this: is to understand. At the moment right now, it's an imagination on how to use these things, right? Depends upon the type of jobs that one want to do. The entire AI scenario is expanding. Like what you say, doing QAs, understanding the data and whatsoever. You don't need someone to have, you know, sophisticated mathematical backgrounds whatsoever, right? So again, it depends on the type of works that one wants to do, and once it's needed. Am I right to say that? Any comments?
Well, I would see in the same way, right? At the end, you need people to solve things and to really create solutions that work. And PhDs, well, at least in my personal experience, of course, are usually way too theoretic and overcomplicate the whole, you know, actually bringing things into production. At some point in time, as mentioned before already, a model is good enough to work and to already distinguish enough what you need to forecast or what you need to cluster or how you need to apply it in your actual operations. So it really depends on what you want to do with your data science team. If you want to have people that actually are able to use the data and give you insights based on which you can make decisions, then probably you don't need a PhD. If you now look into, really improving the way the algorithm by heart works, then of course the PhD would be required. But I do believe that for most of us who sit here, we are more on the application layer, where we really just needed to use it and really drive value through that and not really try to really push the 99.999% out of it.
So I don't have a PhD, but I hope I'm a qualified data scientist. I think I have a lot of friends who are PhD graduates, right? And I'm not going to discredit them. I know that they work very hard and they have gone through the regime. So I think there is something about PhD holders that are very admirable, and they studied really hard and they work really hard for it. But having said that, these are traits that bring them to there, and it's not the end paper that's most necessary to become a good data scientist. That's what I feel.
So I think contrary to that, sometimes having a PhD is detrimental, because like if you're a startup, you just want to get things done, get problems solved. Sometimes PhD might get too specialized in something and they don't have enough experience in various models. So it's more important to have someone who is more passionate and who does a lot of different models on his, or who have experience with different models. I think that's more important. Yeah.
Just want to add one thing. One of the things that we actually look at when we want to recruit a artificial intelligence or deep learning scientist, we look at in his resume, does he has a GitHub? GitHub. Basically, has he contribute codes to the community? What sort of codes, machine learning codes that he has actually written? Whether he come from Stanford, whether he come from some third-rate universities, I do not really care. He has written the codes, and the codes has been heavily used. He is a top candidate.
I'm just I might annoy some people with this, but I think at the moment, from our interactions with the HR teams, recruitment teams are not struggle with recruiting data scientists. So in the absence of understanding what a data scientist needs, they use all these things as proxies and signals. PhD is higher than masters, therefore I want the highest, that kind of very, very simple, very basic thinking. I think for me, if you're starting a data science team from scratch, the first person you want is, again, I agree with what Zane says, you want someone to be a generalist, to go in, see the lay of the land, find the problems, and invest in knowing, in defining your problem, and then the requirements will fall out from there, and then you hire accordingly. So I think the first one, the PhD, is kind of like, I don't know what sickness I have, but let me go for an oncologist, that kind of idea. So you probably want to have a GP come in, diagnose stuff, and then based on that, you know the right specialist to bring in. Or maybe you just need a few GPs.
Last two questions, because I'm having a feeling we're going to be left with as many people as pizzas. One there.
I'm from the media business. I want to ask questions about cost. So basically, Mashable, they are a media company. They built this system called Firehose, something like that. So basically, they track conversations on social media, and from there, right, they determine what is the next trending topic, and from there, their journalists come up with this short story angle. So I want to ask about, like, let's say, for example, you want to like find data and patterns like this, right, to implement something to identify demand. So what is the minimum cost or like minimum team to like establish a system like this? Like it's about cost, yeah.
One person, open source on a laptop.
Well done. Yep, I totally agree with that. And you spend a lot of deep. Actually, in fact, I want to add on that a lot of coffee because you're going to burn through the night.
Not a lot of GPUs.
You can get GPU very cheap off the Siemens Square.
Yeah. I don't have much comment on this.
Well, what to answer to that question? Of course, if you look at the technical implementation, right, there are a couple of components that you would need. Let's say you use Twitter as the basis. It's not hard to basically for free to sign up for an app on Twitter and listen to the fire hose, and they have basically I was listening to Board for quite some time. You get 250,000 Twitter feeds per day, basically, right? So you're collecting already a lot of information. Then using Python, which is free, you can easily set up like a TD-IDF vectorizer on it, and so you can see which terms are often used and which terms are not often used. Then you use a bias. Logic around it to now forecast which is heavily used and which one is not heavily used. And the ones that is heavily used is of course the topic that is trending.
I'm not a technical person, so
it's not
I'm finding it
technical
difficult
yet,
to
right?
understand.
So
basically,
there are some components in place which are open source and which are free, right? So it just depends on your time and effort at the end of the day that you want to spend on it.
Considering what you just said, maybe it depends on the salary level for.
Of course, if you need to find someone that does all of this for you, it might be expensive, yes, to frame it this way.
Yeah, so to summarize, it's actually pretty easy. You just Google for how do I crawl link Twitter or something. Yeah, then you'll get a lot of help, like a lot of resources that you can use.
I just want to quickly address, maybe one of the latent questions you have is like, why are these people saying it's free, and why are some companies spending like X millions of dollars on it? And I think, one thing is there's this like tussle going on in software for a long time between open source and proprietary closed source, and I would say maybe like a handful of years ago, less than a decade ago, we see open source strongly breaking away and matching like proprietary software in many respects. It does need a little bit more work, but right now you have these large companies who build all these like proprietary things from vendors who also do proprietary things, and you have these like whole bunch of different groups of people doing very interesting things on open source. So there's this like big tussle going on between open and closed source, and maybe that might explain why some people do things for 0 and some people do things for 1 with like 6 zeros behind. I'm biased towards open source. I think that in the long run, you probably end up with the end state would be open source winning, in the same way that Wikipedia beat Encarta, and in different markets and different industries, it happens again and again. And I think in a few years, we'll kind of see that in this area as well.
Okay, last question. Abi?
So I know that Go-Jek is like a Go-Jek actually company, and in the start it was just meant for objects, but later you guys expanded into car and food and such. So I'm wondering, like, do you create models that can be shared across all these different completely independent companies? And do you companies have any models that are shared across all these companies?
Yeah, that's a good question. So for right now, we don't really have a model that is universal across service types. We call them service types, so basically different verticals, like Go Food Delivery and Go Ride, the bike, the Go-Jek, and Go Car. So we use different models for different verticals, but that depends on the use case. So like for say customer growth and promotions, targeted promotions, we do have like a just a customer service vertical agnostic model that targets across all the customers across all verticals. So yeah, I think it really depends on on the use case. I think even like for Uber, for example, they have different models for different cities, and it's kind of like hierarchical. So they have regional model, they have city level model, yeah, so yeah.
All right, well, thank you for the questions, thank you for the time, for the attention, and I just heard that food's on its way. Unfortunately, in this fourth industrial revolution, we still have to rely on unreliable logistics and technology, but within the next 5 minutes, so please hang around, meet each other, and talk to the speakers, and thank you.